Welcome to another session of ICCT Online Learning. I'm Jerico Vilog, and today we are going to discuss an essential topic that forms the foundation of modern computing: types of platforms, which are hardware, software, and cloud. Technology is everywhere. It's in the devices we use, the applications we interact with, and the online services we rely on daily. But behind all these technologies are platforms that make everything work together seamlessly. Whether you're an IT student, an aspiring software developer, or a tech enthusiast, understanding this platform is crucial in navigating the world of computing. In this session, we'll break down the three major types of platforms, which are hardware, software, and cloud, and explore how they function both independently and as part of an interconnected system. By the end of this lesson, you'll have a clearer understanding of the essential role these platforms play in modern IT infrastructure. Let's get started. Before we dive into the details, let's take a moment to reflect on what we aim to achieve in this discussion. By the time we finish, you should be able to define and distinguish between hardware, software, and cloud platforms with confidence. We'll explore their roles within the IT ecosystem, looking at how they power the applications and services we use every day. More importantly, you'll gain an insight into how these platforms support the development, deployment, and scaling of applications. Essential knowledge for anyone looking to build a career in technology. Beyond definition, we will also examine real-world examples of each platform type and how they contribute to businesses and technological arrangements. By the end of this session, you'll be able to analyze these platforms critically and understand how they shape the digital world around us. In today's world, technology has become an essential part of daily life. Whether you're sending an email, browsing social media, or running an enterprise level application, platforms serve as the backbone that makes this function possible. But what exactly is a platform? At its core, a platform is a foundation that supports applications, systems, and services. It provides the necessary infrastructure to build, run, and manage technology. Think of it like a stage for a performance. Without a stage, actors wouldn't have to place to perform, and the production wouldn't be possible. Similarly, platforms provide the necessary support for software, applications, and digital services to operate efficiently. There are three main categories of platforms: hardware, software, and cloud. Each plays a distinct role, yet they often work together. For example, when you use a mobile application, it runs on a hardware, your smartphone, while relying on software such as an operating system and application frameworks. In many cases, the app also connects to cloud services for data storage and processing. Understanding this platform is crucial for anyone in the tech industry, whether you're a developer, a system administrator, or a business owner. Knowing how these platforms work together can help you make better technology decisions and optimize your digital operation. Let's begin with hardware platforms, the most tangible and familiar type of platform. Imagine a world without physical devices, no laptops, no smartphones, no data centers. Everything we interact with in the digital world relies on some form of hardware. A hardware platform refers to the physical infrastructure that hosts and supports applications, services, and systems. It includes everything from personal computers and mobile devices to massive enterprise-grade servers housed in data centers. At the most basic level, a hardware platform provides the computing power, storage, and network capabilities necessary for software and cloud services to function. Without it, applications wouldn't have a place to run. Consider a gaming console like a PlayStation or Xbox. The console itself is a hardware platform designed specifically to run gaming software. Similarly, servers power the internet, hosting websites, managing databases, and supporting large-scale applications. The evolution of hardware platform has dramatically transformed the way we use technology. Early computers were massive machines that occupied entire rooms, requiring significant maintenance. Today, advancement in hardware technology have made computer more powerful, compact, and efficient, enabling everything from cloud computing to artificial intelligence. But despite these changes, the fundamental role of hardware remains the same. It serves as the foundation in which all digital applications operate. To understand hardware platforms better, let's look at some real-world examples that we encounter every day. One of the most common examples is the personal computer or laptop. Whether you're running Windows, Mac OS, or Linux, these machines are essential hardware platforms for both personal and professional use. They provide the processing power necessary for tasks ranging from simple document editing to complex data analysis. But hardware platforms go beyond personal computers. Servers play a crucial role in modern technology, acting as the backbone of the internet. These are high-performance machines designed to handle large-scale computing tasks, from hosting websites to processing financial transactions, unlike personal computers which are designed for individuals. Hardware platforms form the physical foundation of computing, providing the essential resources needed to run software and applications. Their characteristics determine how efficiently a system operates and support various workloads. One key characteristic is performance and capacity. The power of hardware platform is measured by its processing speed, memory, and storage capacity, all of which affect how fast and efficiently applications can run. Another important trait is reliability and durability. High-quality hardware is designed to handle continuous operations, whether it's personal laptop or a large-scale data center. Businesses rely on servers and networking hardware that can function with minimal downtime. Scalability is also crucial. Hardware platform must adapt to growing demands. Whether upgrading a PC with more RAM or expanding a data center with additional servers, scalability ensures that system can handle increased workloads over time. Ultimately, hardware platforms served as the foundation for software and cloud computing, making them an essential part of today's technology-driven world. Now that we have explored hardware platforms, let's turn our attention to software platforms. Imagine you have a powerful computer, a high-end laptop, or even a smartphone. While the hardware provides the physical structure, without software, these devices would just be lifeless machines. Software platforms bring them to life, providing the environment where applications run and interact. A software platform is much more than just an operating system. It is the foundation that enables the development, execution, and management of applications. It consists of several key components such as the operating system itself, middleware that allows application to communicate, and development tools that help programmers create functional and scalable software. Think of it as the stage where applications perform. Just like a theater, production requires lighting, sound, and a backdrop. A software platform provides the essential infrastructure for application to function. From the moment you open a web browser, play a game, or run an enterprise application, you are interacting with a software platform that ensures everything operates smoothly. There are different types of software platforms, each serving a unique role in modern technology. The most familiar one is the operating system, which acts as the core of any computing device. Whether you're using Windows, Mac OS, or Linux, the operating system is responsible for managing system resources and allowing users to interact with their machines. But software platforms go beyond operating systems. There's middleware, which serves as the bridge between different applications. Um, have you ever wondered how applications like Netflix can run on various devices, from smart TVs to smartphones? That's middleware at work, ensuring smooth communication between different systems. Example of middleware include Node.js and Java EE, which allow developers to build scalable applications that work across multiple platforms. For software development, there are application development frameworks such as .NET, Spring, and React. These frameworks provide developers with pre-built tools, libraries, and structures that make it easier to create and manage applications. Instead of starting from scratch, developers sorry, developers can leverage these frameworks to build complex applications more efficiently. And then we have databases, which are crucial in managing and storing data. Platforms like MySQL, PostgreSQL, and MongoDB handle vast amounts of information, ensuring that application can process and retrieve data efficiently. Whether it's a simple web application or a massive e-commerce platform, databases play a role in making everything function seamlessly. So, what makes software platforms so powerful? One of their most important characteristics is the vast set of development tools and libraries they offer. These tools provide programmers with everything they need to write, test, and deploy applications efficiently. Imagine building a house. Without a proper tools like hammers, nails, and measuring tape, it would be nearly impossible. Similarly, software platforms provide the necessary tools to construct digital applications. Another defining characteristic is interoperability. In today's interconnected world, applications rarely function in isolation. They need to communicate with other systems, whether it's a mobile banking app, interacting with financial databases, or a social media platform sharing content between users. Software platforms facilitate this communication, ensuring seamless integration between different applications. Customization is also a key feature of software platform. Unlike hardware, which has a physical limitations, software can be modified, extended, and then optimized to meet specific needs. Developers can tailor software platforms by adding new libraries, adjusting configurations, or integrating third-party application to enhance functionality. Finally, software platforms enable efficient deployment and execution. Whether an application is running on a personal computer, in a corporate network, or in a cloud-based environment, the software platform ensures that it functions efficiently and securely. This adaptability makes software platform indispensable in the modern digital ecosystem. Now let's move beyond traditional software and hardware platforms and dive into the world of cloud computing. Imagine a time when a businesses had to invest heavily in massive on-site servers, maintain expensive IT infrastructure, and constantly upgrade hardware to keep up with demand. Cloud platforms have completely transformed this landscape by providing computing resources over the internet. Instead of owning and maintaining physical infrastructure, businesses can now rent computing power, storage, and services as needed. A cloud platform is like a utility service. Just as you pay for electricity or water based on consumption, cloud computing allows businesses to pay for what they use. If a company needs more computing power, it can scale up instantly. If demand decreases, it can scale down, all without the hassle of managing physical servers. Cloud platform offers several advantages. One of the most important is scalability. In traditional IT setups, expanding computing power required purchasing new hardware, setting it up, and configuring it. Often, a time-consuming and expensive process. Cloud platforms eliminate this complexity by providing on-demand resources that can be adjusted instantly. Another major benefit is accessibility. Cloud services are available from anywhere in the world as long as there is an internet. This makes remote work, online collaboration, and global connectivity more seamless than ever. Cloud platforms have revolutionized computing, making powerful technology accessible to businesses of all sizes. But not all cloud platforms are the same. Let's explore the different types of cloud computing models that empower today's digital world. Cloud computing is not a one-size-fits-all solution. Depending on business needs, cloud platforms come in different models, each serving a specific purpose. The first type is Infrastructure as a Service or IaaS. Think of IaaS as renting virtualized computing resources such as servers, storage, and networking infrastructure. Instead of purchasing expensive physical servers, companies can rent computing power from providers like Amazon Web Services and Google Cloud Platform. With IaaS, businesses have full control over their operating system and applications while relying on cloud providers for underlying infrastructure. Next, we have Platform as a Service or PaaS. This model provides a fully managed environment where developers can build, deploy, and manage applications without worrying about the underlying infrastructure. Imagine wanting to develop a web application but not wanting to deal with setting it up. Uh, but not wanting to deal with setting up servers, installing databases, or managing networking. PaaS solutions like Heroku and Microsoft Azure App Services handle these technical aspects, allowing developers to focus entirely on coding and innovation. Finally, there's Software as a Service or SaaS. This is the most user-friendly cloud model. providing fully functional software applications accessible via the internet. Instead of downloading and installing software, users can access applications on demand through their browser. Google Workspace, formerly known as the G Suite, Salesforce, and Dropbox are examples of SaaS platforms offering productivity tools, CRM software, and cloud storage without requiring local installation. Each of these cloud models plays a critical role in modern computing. While some businesses use IaaS to run large-scale applications, others rely on PaaS for development efficiency or SaaS for user-friendly application. Together, they create a flexible and dynamic computing environment that supports businesses in the digital age. In the next section, we'll explore how hardware, software, and cloud platforms work together, forming the backbone of today's technology-driven world. Cloud platforms have revolutionized the way businesses and individuals use technology. Instead of relying solely on local hardware and software installations, cloud platforms offer computing power, storage, and services on demand. But what does this actually look like in practice? One of the most well-known cloud platforms is Amazon Web Services or AWS. AWS provides a broad set of cloud-based computing services including virtual machines, databases, and AI tools. Companies like Netflix, Airbnb, and even NASA rely on AWS to run their operations efficiently, taking advantage of its scalability and global reach. Another major cloud provider is Google Cloud Platform or GCP. Google's cloud services power applications from YouTube to enterprise-level data analytics. With GCP, businesses can access tools for machine learning, big data processing, and cloud storage without maintaining their own servers. Then, we have Microsoft Azure, which offers both IaaS and PaaS solution. Azure is widely used by businesses that require strong integration with Microsoft products like Office 365 and Windows Server. It provides a seamless environment for organizations to build, deploy, and manage applications using Microsoft ecosystem. For smaller scale web development, there's Heroku, a platform as a service that allows developers to deploy web application effortlessly. Many startups and independent developers choose Heroku because it eliminates the complexity of managing cloud infrastructure. This platform exemplifies how cloud computing has become an essential part of modern technology. Whether it's a global corporation using AWS for large-scale applications, a university leveraging Google Cloud for research, or a startup launching an app on Heroku, cloud platforms enable innovation, scalability, and efficiency. Now that we've explored some example of cloud platforms, let's discuss what makes them so powerful. One of the biggest advantages of cloud computing is scalability. Unlike traditional on-premise systems, which require businesses to invest in physical servers, cloud platforms allow organizations to expand or reduce their computing resources based on demand. Imagine running an e-commerce website during a regular day. Traffic might be moderate. But during a major sale event like Black Friday, traffic can skyrocket. Cloud platforms automatically scale up resources to handle the surge, then scale down afterwards to save costs. Another defining feature of cloud platform is cost efficiency. In the past, businesses had to purchase expensive hardware and maintain data centers. Cloud platforms eliminate this upfront investment by offering a pay-as-you-go model, meaning companies only pay for the resources they use. This makes cloud computing especially attractive for startups and small businesses looking to operate on a budget. Accessibility and flexibility are also key benefits. With cloud platforms, data and applications are no longer confined to a single physical location. Whether you're working from an office or at home or traveling, cloud based services ensure you can access files, collaborate with colleagues, and manage operations remotely. Cloud platform has reshaped the way businesses operate. With its scalability, cost efficiency, and accessibility, it's no surprise that cloud adoption continues to grow across industries. While we've discussed hardware, software, and cloud platforms separately, the reality is that they don't function in isolation. Instead, they work together to create the foundation of modern computing. Let's take a simple example. Imagine you are using a web application like Gmail. The experience may seem straightforward. You log in, check your emails, and send messages. But behind the scenes, multiple platforms are interacting seamlessly. First, there's the hardware platform, the device you are using, whether it's a laptop, tablet, or a smartphone, acts as a physical infrastructure that enables you to access the application. This hardware contains a processor, memory, and storage, all of which are necessary to execute software commands. Next, there's the software platform, the operating system running on the device, such as Windows, macOS, or Android, provides the interface for interacting with Gmail. Additionally, the browser you are using, such as Chrome or Safari, is part of the software ecosystem that allows you to load the web application. And finally, we have the cloud platform, which is where Gmail is actually hosted. Your emails aren't stored locally on your device. They reside on cloud servers managed by Google. These cloud servers ensure that your data is accessible from anywhere, provide security features to protect your emails, and manage large-scale data processing in real time. This example demonstrates how these platforms are interconnected. Without hardware, we wouldn't have the physical devices to run software. Without software, we wouldn't have the tools to interact with application. And without cloud computing, many of the services we rely on daily like Gmail, online banking, or streaming platforms wouldn't function in the scalable, efficient way we expect. The synergy between these three types of platforms forms the backbone of digital transformation, enabling everything from artificial intelligence to remote work solutions. As we reflect on everything we've covered, it's clear that platforms are the foundation of modern technology. In today's fast-paced digital world, businesses and developers must choose the right platform to support their applications, services, and operations. For businesses, choosing the right hardware platforms is crucial for performance and efficiency. Companies invest in powerful servers and high-speed networking equipment to ensure smooth operations. At the consumer level, individuals select devices such as smartphone, gaming consoles, or laptops that meet their computing needs. At the same time, software platforms provide the flexibility and tools needed for innovation. Operating systems, development frameworks, and middleware enable organizations to create and deploy applications efficiently. The right software platform can determine how well an application integrates with other systems, how user-friendly it is, and how secure it remains in the face of cyber threats. Meanwhile, cloud platforms have become the driving force behind modern IT. They empower businesses to scale operations, reduce cost, and access cutting-edge technology without needing to manage physical infrastructure. Companies of all sizes, from startups to multinational corporations, are leveraging cloud computing to remain competitive in an increasingly digital world. The combined power of hardware, software, and cloud platform is what allows businesses to grow, developers to innovate, and consumers to experience seamless digital interaction. As technology continues to evolve, so too will these platforms, playing an even greater role in shaping the future of IT. To wrap up our discussion, let's review the most important concept we've covered today. Hardware platforms serve as the physical foundation of computing, providing the necessary infrastructure to run applications and store data. Without them, software and cloud services wouldn't have a place to operate. Software platforms act as the interface between hardware and users, enabling application development, communication between systems, and communication to meet specific needs, whether through operating system, development framework, or middleware. Software platforms play an essential role in modern IT. Cloud platforms have transformed how computing resources are delivered, offering scalability, cost efficiency, and remote accessibility. With cloud technology, businesses no longer need to invest in expensive hardware, and users can access applications and data from anywhere. More importantly, these three types of platforms, hardware, software, and cloud, work together to support modern application. From social media networks to e-commerce platform, every digital service we use today relies on this seamless integration of platform. Understanding these concepts is key for anyone entering the tech industry. Whether you're a student, a developer, or an IT professional, having a strong grasp of how platform function will help you navigate the rapidly evolving digital landscape. Thank you for joining this session of ICCD Online Learning. I hope this discussion has given you valuable insight into the role of platforms in technology. Stay tuned for more lessons, and I'll see you in the next session.
For more ICCT College's video updates, please subscribe and click the notification button.